Well, good morning, everyone. Welcome to what I believe is going to be one of the most consequential conversations that we can have today. Semiconductors power our digital age. AI is transforming our economy and certainly also our security environment and energy. Clean, reliable, and secure is the backbone of both. These aren't actually isolated industries. They form a new industrial base, interdependent, strategic, and deeply geopolitical. Today I have the pleasure of being joined by leaders who have both shaped national policy, built frontier technologies, and steered major institutions through transformation. And together we're going to explore how America can lead with purpose and resilience. So let's dive in. And if it's all right, Madam Secretary, we'll start with you.
Great.
You've both been the prime architect and have led us through historic investments, through the CHIPS and Science Act, through the NTIA broadband digital infrastructure efforts, and to the AI Safety Institute. And what I'd like to ask you is, what should the U.S. do now? What should we be doing to lead globally in AI and semiconductors while ensuring national and economic security?
Yeah, great. Well, good morning, everybody. It is wonderful to be here. I will first say that both the broadband initiative and CHIPS were bipartisan. And I think Senator McCain would have been proud of both of those accomplishments because they were bipartisan and done in the interest of America's national security and investing in America's strength. And so I went to Washington. I had been a two-term governor, and I went to Washington, maybe a little cynical, wondering, can you get things done in Washington? And was very pleased to find out that it is possible to pass consequential bipartisan legislation in the name of America's strength and national security. So I thought, on the occasion of celebrating Senator McCain, it's worth saying, reminding us all of that so we stay hopeful and committed. Hopeful and committed. What do we do now? We have to keep going. We absolutely have to keep going. We heard at dinner last night from our Indo-PACOM commander that there's a race for compute. There is a race for compute. There's no doubt about it. AI is the defining technology of this generation. And we have to lead the world. We cannot be second. We cannot be second to China. We must lead. And all AI runs on compute. So there is a race for compute. Compute is chips, right? And it is dangerously untenable that the United States of America buys 100% of its AI chips from Taiwan, from a single company in Taiwan. And so the CHIPS Act aimed to change that to get back into the business of making that compute in the United States. In fact, right here in Arizona, the first 2-nanometer chip to be made in this country ever is happening just up the road in Phoenix. So, but really that's just I don't want to say drop in the bucket, but it's a down payment on all that we need to do. For example, what about the supply chain?
Yeah, and we'll talk a
right?
lot about
what about the supply chain?
Yeah.
Energy, but not just energy. What about all the components? Right. All the components that go into an AI data center? Mm-hmm. What about all of the materials and chemicals and substrates that go into TSMC's facility? Not to alarm you, but almost all of that comes from Taiwan, China, Japan, Korea. Mm-hmm. So we got to reshore that supply chain. What about talent? I've had 100 hours of conversations with these companies who I was leaning on TSMC, go big or go faster, and they would say, okay, Mrs. Secretary, which is what I was called, okay, Mrs. Secretary, you go find me 10,000 more engineers and we'll go faster. So anyway, where do we go from here? More talent, more supply chain, more investments in infrastructure. What we did in broadband and chips was a down payment. I hope it creates a flywheel, and we continue.
That's a terrific way for us to start. And again, it's just a small plug for ASU. I think we are very much up for the challenge of actually producing the engineers that are required not only for the semiconductor piece of it, but very much focused on partnering with others to bring the talent that's required in the pipeline. And if it's all right, Ryan, I think I'll go to you next, if it's all right. And Shield AI is actually deploying AI in defense, and arguably, as we heard last night, and obviously already the Secretary has put it back on the table, really one of the highest stakes environments that's imaginable. So maybe the way to sort of start this with you, and we'll see sort of how maybe we can come back to it with others, how do we reconcile the rapid pace of innovation with the ethical and the operational responsibilities of building AI for mission-critical deployment?
One, thank you for having me here, and thank you for the question. And I just want to echo what the Secretary said, which is American leadership in AI, I think, is the critical objective for this generation. The investments in semiconductors, the investments in power generation, and the investments in the software are absolutely critical. And I do not believe that there is an industry globally that will not be touched and transformed by the impact of AI and autonomy. The measure of competitiveness of all businesses will be a measure of how effectively those technologies are adopted. We've had the opportunity to work on AI and autonomy for defense and national security applications for about a decade. And while I believe that there's amazing opportunity to make huge and transformative impacts on the battlefield, there's still a lot of work to be done before I think the technology can reach its full potential. Our adversaries, and the Admiral would know this far better than I do, present challenges and conundrums that take away capabilities that we have had for a long time, and we have to get in a state of applying these technologies just to get back to parity. An example is GPS, which in the European theater is severely challenged. And for a long time, you've been able to know where you are in the world when you want to know, where you are. And so one of the big applications of AI and autonomy is just to recreate the basic functioning of GPS. And there's a huge amount of effort and initiative to recreate this basic infrastructure with more advanced software to produce those capabilities. A lot of the questions come up, and I think the Admiral did a brilliant job of framing it last night about, what could be and these big complicated problems. But from where I sit, number one, I think we've got the right people in the seat making those hard choices, both from a policy and in theater perspective. And it's our job to build the capabilities that actually make that a real conversation, because the capabilities are so advanced that becomes the question of the day. And we've got a lot of work to get there before I think we're making the impact that we want to.
Great. So obviously, Jeff, the reality is that AI doesn't run in a vacuum. It runs on power, and it's not just power as we've known it historically. It's power at a scale that is actually mind-boggling at the moment. So let's turn to the energy side of this stack that we've now introduced here. And with AI compute demand surging for reasons that I'm sure everyone now in the audience appreciates, and the push for electrification accelerating, grid resilience, as you and I have been chatting about out in the courtyard here, and energy equity are under huge amount of pressure right now. So how do we meet growing demand without compromising progress on climate or system reliability, which is actually obviously top of mind for everybody?
Yeah, it is interesting to think about this as a stack, because energy is truly foundational. If you think about the U.S. economy, energy is only 10% of the U.S. economy, but we like to say it's the first 10%. So you can't do the rest without that first 10% being there. And of the electric side of the industry, we're about 2% of all U.S. commerce. But everything that we're talking about here depends on electricity. And so that's where the challenge is. And I can tell you, my industry does see this as a strategic imperative. We see it as a national security issue, that we have to win the war on compute, that we have to provide the power resources, not just for AI. I think AI is a big driver. We can talk about that. But it's also for chip manufacturing. And Arizona is a great example to see this challenge of the scale that we're seeing. So we've been around about 140 years. We took 140 years to get to an 8,000 megawatt system. A megawatt is a Walmart. About 750 homes is a megawatt. TSMC, when it builds out 6 fabs with the supply chain and the support, will be 1,000 megawatts. Our largest customer 5 years ago was a mine that was 70 megawatts. And we're now talking about that largest customer being a single load of 1,000 megawatts on an 8,000 megawatt system. The layer below that, which is the data center layer, and there's a tremendous push in data centers. We're still sorting through how we can get efficiencies, what the real number is going to be. There's a lot of duplication that's there, but we know unqualified that it's going to be a big number. And so I think probably between 5,000 and 10,000 megawatts in our system alone. We share Phoenix with Salt River Project. So there's likely another 4,000 or 5,000 megawatts to construct in there. This is an industry that we used to get excited when it's like, we got 1.5% growth, baby. We're rocking. This is fantastic. And now you're seeing, like, how are we going to accommodate this 5 to 7% demand growth that we're likely to see in the future? And I loved what you said about, let's get on it. And that's really what we see, is we need to figure out how we start chipping away at the issues that can get us to that growth. The mix and the generation build-out. That's one component. We have to construct generation. Right now, the easiest to construct, solar. Batteries, but you got to have some gas. And so we got to get that generation mix right so we can have reliability and firm system. Transmission. We can optimize that grid by having better transmission ties across the regions and across the interties in the US so that we can reduce the cost of this build-out. Supply chain is going to be a huge challenge, just because if I ordered today, called GE Vernova and said I want a new gas turbine to put on the grid, 6 years.
Let that sit in. Let that sink in.
6 years. Now, we can juggle spots in the production queue and things like that. Transformer, and we'd worked on transformers before. A large transformer, typically coming from either Europe or Korea, 5 years. And every one of these data centers needs a substation that's going to step the generation down into that, in that data center. So we have to get better on that. Also not well understood is workforce. When TSMC came in, we've got 2,000 employees at the largest energy producer in the US. I know Senator McCain was a huge supporter of Palo Verde. Radiation protection folks, instrumentation, they all started coming to TSMC. We've got to get a workforce that's going to be able to support this expanded economy, and manufacturing overlaps with energy in those contexts.
So Jeff, let me just, and a lot of capital. Let me just stop you there, because you've made things complicated, and I want to make things even more complicated right now as we sort of open the aperture a bit further and take a look at it in sort of the global context that's underway here. And I guess the big question to all of you, maybe we'll go to the Secretary again just to start us here, is can America go at it alone? I think there is a bit of a wind shifting out there in which I think certainly in this convening it's worth asking a tough question along the way. Or do global supply chains, shared standards, cross-border R&D, make interdependency maybe not only inevitable but essential in building this new industrial stack? What do you think about how we should effectively be framing it? It's good to, in many ways, thump our chests and saying if all we need to do is figure out how to onshore. Realities checks in, lots of complexity. How would you help us frame? Go at it alone, go at it with allies, go at it intentionally interdependent, or some other formulation?
Yeah. We cannot go at it alone. Furthermore, we should not want to. In fact, quite the opposite. All of the world's truly leading AI companies are American. So we want to use that as an advantage to share with the world and draw the world toward us. And by the way, if we don't, China will. Mm-hmm. We made that mistake already with 4G and 5G. all of Africa, all of Latin America, all of the global south, all runs on Huawei. Why don't we learn from that lesson and say, with AI, we want the world running on American rails, not Chinese rails. Yep. Furthermore, anyone who's a technologist, Ryan is an expert, knows diffusion is the name of the game. Yep. So let's diffuse our technology, but do it in a way that is smart so that we draw the world towards us and which allows us to go faster, but not let our best, technology get into the hands of the Chinese. One of the last things I worked on as secretary was a rule called the AI Diffusion Rule. And what we tried to do is to set up a kind of a taxonomy of countries that shared our values and would make it easier for them to receive leading-edge US chips. And did we get that perfect? No, because nothing's ever perfect. But the concept, I think, is correct, which is our chips are better than Huawei chips. We always want to be relatively better. That secures us. So therefore, we do want to block the Chinese to the best extent we can from getting the most sophisticated semiconductor equipment, the most sophisticated chips. That being said, we want the rest of the world, including people who don't line up perfectly with our values, right. Maybe the UAE, there's tough calls to be made, to have our chips, to run on our rails with cyber and physical security conditions. And I remember vividly, and this goes exactly to what Jeff's saying. You're talking about the compute power and the electricity power. An AI data center that, say, Amazon wants or OpenAI wants, they're talking about a gigawatt, right? A gigawatt, 2 gigawatts, mind-blowing amounts of energy. And I had a conversation with the CEO of Amazon, who wanted us to allow more chips to be sold to India and Malaysia, for example. And I said, we don't want to do that because we want your biggest data centers to be in the United States, right? We want the Holy Grail training to be in the United States. And he said to me, so do I, but where do I get the energy? That's a real, you talk about complexity. Right. So these are real life trade-offs. Right. CEO of one of the leading companies, he said, okay, Gina, I want that too. Go get me a few gigawatts of energy and I'll put them all in the US. But we can't deliver on that.
Jeff, do you want to just pick up on...
So we need allies is the point. We need allies that follow our security protocols so that we can go faster, because we don't want to slow down. We got to beat... The way you beat the Chinese is running faster.
Right,
but
and
we need allies.
I might just offer that in addition to sort of the hard technology piece of it, there's also gray or soft power that we could be yielding as well here. Maybe we'll find time to come back to that. But Jeff, do you want to sort of pick up on, again, the hard nut questions that are really in front of us here? And maybe just, if I could ask you, just open the aperture a bit further, not only directly on the energy, but the supply chain piece that started the conversation. Then Ryan, we'll go to you.
Yes, I actually think it's really important to build on this what I'd call feather again, because it's we can actually do a lot for a while, and then we hit a roadblock. And that's part of the challenges. So right now, everybody wants their 1,000 megawatt day. These 2,000, that's the size of Portland. Yep. That's the electric load of Portland, Oregon. It's a big challenge to build that in a weekend. And so, but we've cleared on our system 4,000 megawatts to move forward. So we have a plan with stuff we know we can get built reliably with solar, batteries, putting all that on the grid to get 4,000, almost 50% increase on the size of the system. Then it's going to take gas. And then we have to put a gas pipeline in, and then we've got to get those turbines with the 6-year lead times and do that to firm up the next incremental load, because we actually run into what's called an energy deficit overnight. We don't have energy from 11 p.m. to 7 a.m., and there's no way to get it other than a nuclear plant or gas. So, but we can feather into that. So we can do a lot and then begin to make the steps and then maybe lean on allies to say, hey, come in and help us over that time.
Jeff, do you want to say a little bit more about sort of the ways in which we might unlock additional American innovation around the nuclear play, if for no other purpose in terms of timelines, short to medium range? What's your take, your insight? Obviously, it's a non-trivial strategic move as well.
Yeah, nuclear is a geopolitical issue. I just say right now, don't count on nuclear being in the near term. That's going to be more. We may see some U.S. nuclear in government-owned utilities in the 2030s. We're a $10 billion company. We're not going to bet the balance sheet on a nuclear plant in the 2030s. We're going to wait until 11 of them. We want to be number 11. We don't want to be number 2. And so, but we can get there.
Unpack it. Just unpack that. Why is that?
The financial risk to do the early ones, the cost will come down as we build more nuclear in the U.S., but the first one's super expensive. Yeah. And so we have to figure out a way over the financing hurdle, which is let's deploy those plants. That's why Tennessee Valley Authority, government utility, is building the first SMRs, small modular reactors in the U.S. As we scale those, the cost comes down, and it becomes more doable for a company of our size to do nuclear. We operate the biggest nuclear plant in the country right now, so we can't finance it. But we do have to get over that. I'd say that's gas bridge, nuclear picks it up in the 2030s, 2040s, right. And we can continue to decarbonize.
Great. Ryan, I mean, as you sort of hear the conversation around the complexity of the relationship between energy at the foundation, chips and the race on chips and AI, do you see the defense play here as a way of American ability to project and amplify its advantage, or do you see, I think you framed it in the opening as also an area where we needed to, quote unquote, catch up?
I think the Secretary is right when she says that the United States is a leader in AI. And I think that American power comes from like the full gamut of the country, right? Building on our values, the economy, our military strength. And so leadership in AI, from my perspective, is about every company in America leading the world at what it does. When I hear about electrical power and chips, the thing that I think about as a CEO, it's like running payroll for me. If I can't run payroll, I will cease to exist as a company. And it doesn't give me any asymmetric advantage to be able to run payroll, but I know that if I can't do it, I might as well pack up and go home. And so power, chips, these things are fundamental to the existence of the industry and the competitiveness of America over the next 20, 30 years. Now, the question about international partners and working together, I think was a great one, and I wholeheartedly agree. A lot of times when we think about international collaboration, and a lot of the news, of course, because of what's going on with the administration and the tariff policies and so forth, a lot of attention is drawn to the physical supply chains and the movement of goods around the world. What is not as appreciated, I think, is the software factories that exist in the world. The ability to ship complex, excellent software with velocity is a very hard problem, and it's one that's solved by Microsoft, Amazon, and any great software company has built a software factory that lives at the intersection of high performance and high assurance. And when you get more users on your software factories, you're achieving economies of scale. So AWS, Microsoft Azure, Shield AI should have the capability to work with international partners with the guidance of our policymakers to make sure that we're achieving economies of scale in the software production facilities that we're creating, to make sure that we are leading at not only the shipping of AI capabilities, but we're leading at the design and delivery of autonomy and AI factories.
Yeah, and just to state for the audience who may not quite understand all of the interdependencies associated on a global basis, all the interdependencies for coding following the sun. So, conversation just before on Ukraine, some of the best coding factories that we have. India, critically important, and all of those obviously are critical to velocity and to keeping, that interdependency continuing to bring us value, and we don't want to put that at risk clearly along the way. If it's all right, maybe The next round, I'll even try to amplify or extend this out further around strategy, and maybe pose a somewhat controversial framing, which is around strategic prioritization. Can we do it all at once? Can we do chips? Can we do power? Can we do AI all at once with the investment required? Picking up, Jeff, I'm going to let you start with this one. When just alone in the power space, there is significant challenges to overcome. A once in a century, maybe, opportunity coming out of a crisis to get the entire country bipartisan focusing in on unprecedented infrastructure investments. That is obviously going to be very hard to sustain going forward. But can we do it all at once and still remain strategically focused? And how do we perhaps be more selective but still maintain the long-term focus at moving all of the ships forward?
I think you have to take some of the margin that we're used to having and really look for efficiencies, make sure that we're doing it right, that we're putting every dollar to good use, to effective use. You know, in the back 10 years ago, it didn't matter so much if we put a power plant in and it didn't actually consume power or provide power fully for 10 years. We can't do that. We have to be very efficient. There's a lot of work in the industry with data centers and AI in particular to see, can we actually shape that load? There's work being done that says maybe we can virtualize and move the AI load off one data center in an area, maybe we're having a hot day, so we need the power, shift that over to a different data center, and then we can supply that power to homes here in Phoenix. We're going to have to work better together. There is a disconnect right now, I'd say, between the electric companies and the tech side on what's realistic or how we do it. But if we do
and
it,
maybe that's why this is a very important framing of the stack, of the new industrial stack. Please, Secretary.
It is a stack, like Jeff said. Look, we don't have a choice. You have to do it all at once, period, full stop, right? In the 10 years after President Kennedy said we're going to put a man on the moon, this country tripled the number of PhD chemists it produced, quadrupled the number of PhD engineers it produced. We have a moonshot, lead the world in AI. That requires us to improve our permitting. It cannot take, as it takes now, 4 years to permit a semiconductor facility. Cannot. We will lose. We need to improve our permitting. We need to act, as we did with chips, on a bipartisan basis. We need to create a flywheel of training people. You want to talk about national security? It's not just tanks and missiles and foreign affairs. It's training Americans to do these jobs today. All Americans, not just the ones that can afford $80,000 a year to go to college. We must change our system of training. That is how we lead the world. Energy, same thing. Innovation, same thing. We have no choice. We have to do it. We have to do it fast. We have to do it all at once. And we have to unify as a nation behind that goal of leading the world in AI and bringing the world towards us. And if that's our goal, leading in AI, then all the rest of it flows from it. And when I first was pitching Congress on the CHIPS Act, I said, this building, if all we do is build a few fabs in the United States because of the CHIPS Act, we have failed. Yep. That is a failure. Instead, we need to use the goal of leading in AI and chip production to start the flywheel of innovation, which will allow us to achieve the other goals. So my hope is a decade from now, we'll look back upon this moment of choosing to lead in AI and say, this was the beginning of training, tens of thousands of engineers and coders. And by the way, people know how to make things, right? People know how to make things. Not that long ago, the hot major at MIT was electrical engineering, right? Very good. Okay, look at Ryan. Ryan's a young man, right? I'm a slightly older woman. But when we were both in college, half of undergraduates at MIT were electrical engineering. Today, more than half are computer scientists. Now, we need computer scientists. AI is code. Got to write with code. We also need people who can make things. we have completely ceded that ground to Asia. So let's get back into the business of making things, and let's find the young Americans, train them, Americans from all over this country, rural, urban, inner America, coastal America, and point ourselves toward that goal. And yeah, we've got to do it. We have to do it all at once, at the same time, at pace, if we're going to win and if we're going to lead the world.
Well, that's very well stated, and I think definitely worth. So with the time that remains, maybe I have one last question, and maybe Ryan, we'll start with you if it's all right, which is a bit of a crystal ball piece of it. Obviously, as we've heard this weekend, and as we're all experiencing and witnessing, things are moving. The cycles are getting shorter, and the dramatic changes are happening at really geometric as opposed to arithmetic kinds of scale. So, but in the next 12 to 18 months, which is probably the only amount of time frame that makes much sense for us, what dramatic change do you think we might see? And if I can just sort of ask the other side of it, what might we be surprised in seeing actually be sustained over the next 12 to 18 months that you think might otherwise be subject to some disruption? Either choose one or both of those kinds of pieces. And Ryan, if it's all right, we'll start with you, we'll go to Jeff, and then we'll finish our time together with the Secretary.
Yeah. I don't have strong opinions on what the surprises might be over the next 12 to 18 months, so I'll reframe the question for myself, if that's okay.
In 90 seconds, you can do whatever you like.
I believe that there is tremendous opportunity and risk over the next 5 to 10 years. I talk about chips and power generation being the things that you better do, otherwise you might as well pack and go home. But the asymmetric advantages that the country enjoys today in the area that we're talking about is chip design, where the best chips can be 10 to 20 times better than the ordinary chips. And AI models, where the best models can be 10 to 20 times better than the average models. And so the rate of change there is extraordinary. And if you look forward, people are forecasting, between 30 and 100x improvement in AI performance per unit, call it power, over the next 5 to 8 years, with far greater increase in demand, which is driving underlying need for chips and power. But the risk is that as we're executing the all of the above, we find ourselves on the wrong side of asymmetry, where an adversary or another country finds a 10x that we hadn't thought of, or finds a 100x that we hadn't thought of, and we find ourselves in a tough situation. And so I think the fortunate position that we start in is that our AI companies lead the world. Our chip designers lead the world. But because that technology changes so fast, it introduces strategic risk of surprise. And I don't have any great advice on how to deal with it. I think the Secretary's comments on ensuring that we have the best and most talented people in this country are the right place to start.
All right, Jeff, I'm going to see if you want to take on my version, or you can reframe too. Go right ahead.
I kind of forgot the question, but I'm going to go with what I think it is. I think we're going to get better at collaborating, and we're going to rationalize some of these numbers that are more press release numbers, and we're going to figure out what do we really need to do, how do we better collaborate. Just quickly on the supply chain, a lot of the data center companies have gotten transformers and the stuff we need, and they've taken it out of the supply chain. And so we've got to figure out how can we work together and collaborate better to build the stuff we need in time to meet the demands that we need to meet, because it is a strategic imperative that we meet them.
Yeah. No, I agree completely with Jeff. It means we need to do more. We have to figure out a way to produce more and faster. And some of that is embracing more automation. We have to innovate. We have to innovate so that we can do more and faster. And I also agree fully with Ryan, which is this. We cannot assume that we'll always be in the lead. At the end of the administration, I was quoted as saying, trying to use export controls to hold China back is a fool's errand. And many criticized that. I stand by the comment. We need export controls because we have to slow them down where we can, But the only way to win is to out-innovate. And you cannot assume that America is so far ahead, particularly of China, in this innovation, because we're not. We are ahead, exactly as you said. But in order to stay ahead, we have to wake up every day and work at a pace as if we're behind.
That sense of urgency.
Urgency, every day, urgency. And President Xi's view, which is one I strongly disagree with, like democracy's too slow, right? Democracy's too slow, you can't win in the age of AI. So we have to disprove that. But unfortunately, as I was explaining with our permitting example, there's a lot of reason to believe our democracy needs to be fixed a bit. In fact, Senator Kelly left, but one of the things that he did is I worked with him and Senator Cruz, bipartisan, to pass a piece of legislation to change the environmental permitting with respect to semiconductor facilities.
Made a huge difference in Arizona.
Made a huge difference in Arizona, and it will make a difference in Texas and Ohio. So, we have to assume, and the other thing is, we can't be so chauvinistic and naive to say, well, the rest of the world will just come to the United States. They can wait and just wait for our chips. They won't wait. We cannot assume that these other countries will wait. We can actually assume China will be there aggressively offering a cheaper alternative, maybe not as good, but cheaper. So I guess we have to find a way to speed the work that we're doing in this area if we're going to always maintain our edge, which is where we need to be if we want to be safe.
Thanks for the clarion call. Ladies and gentlemen, would you please join me in thanking our terrific panel?